So what is ADT? Abstract data types. Okay, abstract data types of the sparse matrices. So it is represented in the form of a triplet, that is row, column, and the values, where the rows and columns are integers, and the form of unique combination, and value comes from whatever the set of matrix is. But the sparse matrix is number of zero elements are present. Okay. So we'll see some of the functions related to, we have already seen some of the functions, that is creating a matrix. Obviously we need a number of rows, maximum number of rows, and maximum number of columns we have to specify. What is transpose of matrix? Is writing or representing a matrix for the current matrix, where whatever the elements were there in a rows will be represented in form of a column, and the column elements will be represented in a row format, in a rows. So what it will return. So to perform a transpose of a matrix, I need only one matrix. So I will be considering, or you will take it as A. So what it will return, the matrix produced by interchanging the rows and columns value of every triple. What are the triples now? Row, column, and value. All the triplets will be changing in the column form. Whatever was there in the column form will be in the row. Adding two matrices, we need two matrices. Okay. And if the dimension of A and B are same, then return the matrix produced by adding corresponding items. So if for adding, we should see that both the dimension of A and B are same. One into 3 or 2 into 3 or whatever. The dimension of row and column should be same. Otherwise, what it will happen, then they will use identical rows and values. Otherwise, it will return an error. Why it will return error? Matrix addition cannot be performed if the dimension of both the matrices are not same. Next operation in a matrix, or next function is we are using is multiplication. So what is the condition we need to take care while multiplying? The number of columns in the first matrix should be equal to the number of rows in the second matrix. So here we have considered the matrix as A and B. Okay. And we return the matrix D. So to multiply, it will return the resultant matrix. So here the resultant matrix is written as D, considered as D, which is produced by multiplying A by B. So this formula you have used in your C programming first year's CPSD lab. D of ij, that is the resultant matrix row and column. I is row, J is column. Okay. What we are going to do? We are going to multiply the columns into rows. A of I k into B of k j, where B of ij is the ith and jth element based on the row and the column. This you are familiar with matrices. Matrix. What is the transpose of matrix? Interchanging the values in the rows to columns and columns to rows. So what we need? How many matrices we need? How many matrices we need? Do we need one matrix or two matrices? For performing the operation of transpose, how many matrices do we need? We are not multiplying or we are not adding. We are just interchanging the values of rows and columns. So only one matrix is enough for performing the operation of transpose of a matrix. Now we have to see the terms A and B. So B is a set of a transpose of A. Uh, Resultant matrix is different, but performing for performing the transpose, we need only one matrix. And to store that resultant matrix after interchanging, we need one more matrix. Okay, so that is considered as a resultant matrix. So here we have the variables called as n, I and j. So and current values of b. So the matrix is considered as b. Now zeroth index. So total number of elements. How many number of elements we have? To a of 0 dot value. What I'm doing here, we are accessing the value. What is the index? What is the value? Okay, total number of elements. Next, b 0 dot row is equal to a of 0, sorry, a of 0 dot column, which means the b has to be stored in a column form of row in the matrix A. Okay, rows of the matrix B is equal to columns of the matrix A. Next, columns of the matrix B equal to rows of the matrix A. Okay, starting from the zeroth row, it should be writing in the zeroth column of A. Starting from the zeroth column of B should be transposed in the form of 0 to so whatever the values we have stored are the number of elements. Okay, so this is the temporarily we are exchanging the values here. Finally, whatever the values we have in B is the number of elements. Okay, so if n is 0, obviously for a transpose operation, perform an operation of transpose of a matrix, there should be more than one elements. Okay, more than 0 elements. We cannot consider non-zero matrix. So current B is equal to 1. So it will start from the first index of the matrix A. Okay. So A is your matrix, B is your resultant matrix. So we have already written the conditions here. Whatever the values of A are there will be stored in B. Okay. So we'll perform step by step or iteration by iteration, starting from I. I in the sense it is a row. Zeroth row, okay, A of 0. If I is less than A of 0 dot column, then I plus plus A of 0 dot column in the sense whatever the value we have in A of 0 column, then transpose by the column in A. So this is your column. Next we are going to find the this is your rows. Next we are going to find the column. For j equal to 1, j less than equal to n, j plus plus. Next we are finding the elements from the current column. So if a of j dot column equal to I. Okay. So again, you don't worry if you are not understanding what I'm explaining now. Just happening. Okay, if it is not possible, don't worry. I'll be explaining with the example. Okay, we will take some numbers in the matrix and then I will trace the same matrix. Okay. So here I'm going to just explain the logic what actually is happening to the uh, rows and columns of the matrix. Okay. Now the element in the current column we have to add it to B. Okay, so it has reached from A of I, it has ith column to J it has come, and whatever the elements we had in B, we have brought it to sorry, we have reached to the end. That is column equal to I. Now we are going to store or we have to add the elements to B. So B of current B dot row is whatever how we have to store A's column should be B's row. Okay, B current B dot row. What are the values it will be having? A's column. What are the columns we have? A's rows. So whatever the values we have in the current B, okay, current matrix of B, that is nothing but A of j's value. Then this is for the, so we have implemented row, we have implemented column. Again, when we are shifting that, again we are implementing b, because b is the resultant matrix. Okay. Then we are going to end with each of the loops. Okay, end with each of the loop. So after uh, after performing the first values, again it will check for the next row of the A. It will check for the next column of A. It will check for the next row of A. Again perform this and so on. So this will until it reaches the number of elements.